So in the last session, we saw how our first Spark job works. Spark job one, which is nothing but Omniture prepare Omniture data. Omniture is nothing but our clicks data. So we adjusted the timestamp to 2017 and we also did sessionization. Next, we'll see now how to I mean to say how to prepare the sales data. So this step we did see. Everything is explained in that document. Prepare Omniture data. So the file name is prepare omniture data.scala. First, we need to read the Omniture data from raw tables, from the raw Omniture Hive table for specific R. So the partition is nothing but our R. Then adjust the timestamp to 2017, sessionize and compute session ID and session duration. As I said earlier, session duration is not mandatory. We can ignore that as well. If at all you want, you can also compute that. After that, create a processed inside the processed DB, create Omniture table. This Hive table is again must be partitioned on R, just like our raw table is. Then insert or save sessionized Omniture data to this processed Omniture Hive table. To run this program for IntelliJ. From IntelliJ, you have to just give this argument hyphen date underscore ts and the newly created directory, newly created R directory, for example, in this fashion. Similarly, this program will create a Omniture table if not exist in the processed DB and insert processed Omniture data to the table. So that's our output. So next we'll see the next step. I mean, all these things will happen automatically, but to run on a development environment, we have to run it manually. So next, what we are doing? Then we run our prepare sales data. Then the file name is prepare sales data.scala. So it will read raw sales data from the raw sales Hive table. Read previously processed Omniture data. I mean, not previously. Read the uh, processed DB, processed Omniture data from which is from the previous step. In the previous step, we had saved our processed data. Even we need to read that data now. Here also we need to adjust sales data timestamp to 2017 so that it matches Omniture data timestamp. Similarly, change customer ID of the sales data so that it matches Omniture data. Because we know that these two are different data, we have to match the timestamp as well as the user ID. Because there it is some other user ID has purchased, here it is some other user ID is being browsing the website. So, but we need to make that both the user IDs are same. So that is the ETL we are doing in this case. After that, again, create processed.sales Hive table. If not exist, then save that process sales data to this table. Again, this will be also partitioned on the, it will also be partitioned on the hourly basis. It's the same. Only thing is we will be adjusting now timestamp and the user ID. Let's see how we are doing that. So this is our, we already saw prepare Omniture data. Next we have prepare sales data dot Scala file. So we are reading our raw sales Hive table as usual. So we have our raw data reader utility class, utility object. There we are having a read method, read sales Hive, which will directly read from the sales table. We will directly read from the sales table. Hive context.table, specify the table name, and then only read the required data. This will make sure that it will only read the data belonging to that partition directory. It will not read the complete data. So either you can give it in this fashion, or you can write an SQL query in this fashion. Select star from Hive table where date ts equal to whatever date we are having, and run that Hive query, just like you run the SQL query. Similarly, next we are reading our Omniture data. Next we are reading our Omniture data, and we are reading from processed database, which was processed in the previous step. So we got our Omniture data, we got our sales data. So here idea here is first we need to get the user ID mapping. We need to get the user ID mapping. So meanwhile, we need to start dfs.sh. We'll also start the Hive server. And we'll also start beeline. Downloads, training, Spark, source, main, resources, demo data. So if we see here, we know that if we go to the Omniture raw, Omniture. So here, this is our user ID. This part is our user ID. If you see similarly for sales, So here it is as customer ID. So these two things we have to match it. These two things we have to match it. How do we match these two? Match in the sense, I mean, this has to, this user ID we have to bring into this sales data. We should ignore, we should ignore this column because it doesn't make any sense if we use this column. We have to bring this column, these values to our sales.csv file or sales data frame. We will ignore the customer ID column. So how we are doing it? So first we are getting all the distinct customer ID. On the sales data, we select only the customer ID, which will give all the distinct, and we are saying distinct, and finally collect we know that is an action. So we get all the distinct sales ID, which is nothing but these things. This these are all our distinct customer ID. I think almost all are same in this head. We'll get more and more distinct ID. Similarly, for Omniture, logs, we'll get the distinct Omniture IDs. So the idea is something like this. We have our sales data. We'll say it as a sales data frame. We have invoice, invoice date, item purchased, description. We have customer ID. So what we'll do is we will create one more data frame. One more data frame where we will have customer ID and user ID. Because how do we bring this user ID to this data frame? We want to bring this user ID to this data frame. So how do we bring that? We can bring that by joining this data frame with this data frame. To join these two data frames, there has to be some common column. So that common column will make use as customer ID. These two are common column, hence we will be creating one such data frame. We'll join these two data frame and then include this column into into sales data, includes user ID column to the sales data frame. So that's the reason will be creating a data frame with the customer ID and user ID, just a customer ID and a user ID. So that's the reason we took distinct customer ID, I mean to say distinct customer ID and distinct user IDs from the Omniture logs. So only thing we are what we are doing here. So one thing, if you remember, this is a, when we say collect, we get an array. If you see this is an array of row objects, because we we know that each data frame is a row object. Each data frame is a collection of row objects. So after we do a collect, we know that it returns an array. Now it will be an array of row objects. It will not be array of user ID. it will be array of row objects. From that we need to extract the user ID. I mean to say, so you have an array which is sales. We have one more array which is omnichures. We have row 1, row 2, row 3, so on. This is how the data will look like. Here also we have row 1, row 2, row 3, and so on. This is how the data will look like. Inside this row 1, if you see, inside that you will have user ID and its value. So the column is user ID. Similarly, row 2, inside that you will have user ID column. This is for your Omniture data. Similarly, for sales data, inside the row object, you will have customer ID column. Customer ID column will be there. Now what we are doing here, actually there are very lesser sales record. There are very less sales record, just so that we get more sales, to showcase that there are more sales in a particular session. We are tripling the sales record. Only that's the reason. We will be just tripling the number of sales that we want to have, because we were not getting much sales in a particular sessions. Most of the sessions were showing null. When the final query was given in a particular session, we were not seeing more and more sales happening. Hence we are tripling here. Plus plus will add those elements, a collection to. I'll just showcase how it looks like. It's a Scala syntax. So if I have val a is equal to list of 5, val b is equal to list of 6, 7, 8. So if I say val c is equal to a plus plus b, so as you can see, this is what it does. It will just add all the IDs there, 3, 4, 5, and it will just append the elements of the second collection to the first collection and return a new collection. And that's what we are doing here. And the reason why we are doing that is so that we can showcase more sales in a particular sessions. That's the only reason. So we get now more sale IDs, more sale IDs. After that, our goal is this. Our goal is to create a data frame like this, so that we can join it with the sales data frame and put this user ID here. Put this user ID column here. So all these things we are doing so that we can create our this joint user ID and customer ID data frame. So we will zip this sales ID and the Omniture ID. Now zip is again a Scala syntax. So let me showcase what a zip will do. So let's say we have user ID as a list. User ID will say as A, B, and C. Oh, sorry. Customer ID, what we'll say as a list of 1, 2, 3. We have user ID and the customer ID. So let's see what the zip will look like. User ID zip, customer ID. So it will create a tuple here. Whenever we use the zip, user ID zip customer ID, zip command, zip function, what it will do is it will take an element from here and a corresponding first element from here and make a tuple as the first element of the result. B2 and C3, this way it will do a zip. So we got a collection now. Now we got a collection of tuple. We got a collection of tuple. But internally, if you remember, it is a row object. So internally, we know that internally it is not like actual 1, 2, 3 and ABC. Internally, it will be a row object. So we can check that. If you see the zipped data, it is an array of tuple, and tuple first element is also row object, second element is also a row object. And internal to this row object, there is user ID and customer ID. So we have to get those things here. So that's what we are trying to do. We are doing a zip to list and do a map transformation and actually get the customer ID and then get the from the second element. I showed you how to access the columns from a row object. The columns from the row object is accessed in this fashion. And M is a tuple because each element of our collection is a tuple. Tuple's first element is one row object. From that row object, we are getting our customer ID. Tuple's second element is again a row object. From that row object, we are getting the user ID. So if you see that, then we just convert into a data frame. I said this also, we can convert a collection to a data frame also. We showed that. A normal collection has been converted into a data frame with sales ID and Omniture ID. So let's run this program and check only until here. We'll not run the complete program. I'll comment the rest of the code. So we'll just see how we have created this data frame. Again, what should be the input for this? So we have to specify the date, which date of the data it has to pick from. So we have to pick the data from this date. We have only the data from this date. Obviously, we have to specify this. Sometimes, when we automate it, multiple folders will be there. So corresponding folder should be taken as the input. In our case, it's only one as of now. The table, which table we have to read, those things are already there in the configurations. So let's run this program, and I hope I have commented other things. So as you can see here, there is some bug. I think these things should not come. But anyway, uh, there are some bugs here. I think I have to rectify that. Anyway, this is what we wanted to say. We have our sales ID, and we have customer Omniture user ID. This is the sales customer ID. So this we got this data frame, customer ID and the Omniture's user ID. We created this. Similarly, we need to adjust the timestamp. If you remember, this date is something different date. Our Omniture data has 2017 timestamp, and we have converted the timestamp to this, and some minutes and hours, some random numbers are there. Now our sales data also should have the timestamp in this form only. I mean in this range only. We cannot have a sales data in 2015. It doesn't make sense. The user is browsing in 2017. How could a purchase can happen in 2015? So we have to make sure that all our timestamp is also in the uh, in the same 2017 range. So again, what we'll do is we'll create one more data frame. We'll create one more data frame where we'll have some ID and a timestamp. So this ID will be starting from 1, 2, 3, so on. up to number of records in the sales. In the sales somewhere we have 54,000. 54,000, around 54,000 we have. And here we'll have the timestamp. So we will create a, this will be all in the 2017 timestamp. Now how do I make sure that this column is added to our sales data frame? How do we make sure that this column is added to our sales? We will take the same approach. I mean, there are different ways to add this column to the sales data frame. We will take the same approach that we did in our previous approach. So this is our sales data frame. So we have invoice, we have store ID, stock ID, description, customer ID, everything. Now how do I add this new timestamp to this here? Obviously I have to join these two data. But how can I join this data? There is no common column. There is no common column to join this data. So what we'll do is we will use a with column, and we'll also create a column and say 1, 2, 3, 4, 5, so on. We will just create a new column in our data frame, and that new column will match this column. Now we can join on these two columns. After joining, add this timestamp here. So that's the idea here. I mean, there are different approaches to add a column. This is one of the approach. This is one of the approach to add a this column there. So let's see how we are doing that. That is our next. I mean, it is not straightforward to adjust the timestamp and the add that user ID. So all these things is, you can think of this ETL process. Here I'm doing a fake kind of a ETL, but in case of things, some other ETLs could have been. So we have 54,1909 records, the sales. So that's the reason we are looping from 1 to this. 1 2 means this is a Scala syntax again. This is again a Scala syntax to create a numerical collection. To create a numerical collection. I will just showcase that once on the Scala prompt. So if I say val r equal to 1 to 10, so it will create a collection from 1 to 10. Range is a collection. Just like we have a list collection, we have a vector collection, we have an array collection. In a similar fashion, a range is also a collection, which is kind of a out of box implementation for numerical data. Anything you want to do with some numerical data, you can always use a range collection. In a similar fashion, if I say, let's say r1 equal to 1 until, so here the last number will not be used. It will generate from 1 to 9. Just like you used to say in the Java, for I is equal to 0, I less than equal to 10, something like this. But we should not hard code count in code. Can we make it dynamic. Yeah, we can just read the data frame and say count. We can do that. Here is a question. Here the question is, we are hard coding that code here. We are hard coding these things. But we can here what we can do is we can do a collect. Instead we are doing collect, we can run something and do a count also. Sorry, not distinct, but instead of read the data frame and do a count, so we'll get the total number of sales. That way also could be done. Yeah, that's true. We should not hard code it. We can count the total number of records, then we can do it. So as I was saying, so 1 to 10, so these are all your collection. It will create a collection. By default, it will be incremented by 1. By default, it will be incremented by 1. If you want to increment it by some other delta value, so we can say 3 here. So it will give a collection starting from 1, and the next increment that will happen is by 3. Again 3. Similarly, you can specify anything. 1 to 10 by 4. Increment it by 4 and give the collection. 1, 5, and 9. So this R range collection helps us in uh, helps us in using the numerical collections for some purpose. If you want to loop through this, if you want to loop through a collection, but you want to increment it by 1 or 2 or 3, you can use this range collections. Usually they are used in the for loop. Again, as I said, everything that we create in Scala is an object. Everything that we create in Scala is an object. 2 is actually 2 is actually a method on the integer class. 2 is actually the method on the integer class, and we are passing 10 as a parameter to that 2 method, to this 2 method, and it returns a range collection. This returns a range collection, we know that. And by is a method on that range collection. By is a method on that range collection, and we are passing 4 as the parameter. So internally, this is how it works. First 2 is the method on the integer class. By is the method on the range collection. We can chain as we want, because all these are all immutability functions. It takes a it takes some collection and returns something. It takes something and returns something. And on the return value, we can directly call the method of that class. So that's the consequence of having a functional style programming. A good consequence of having we can chain multiple functions in one go. Yeah, coming back to this. So we are generating, we get our collection now. We get our collection. We do a map transformation and convert it into a tuple. We take each element, which is a numerical value. First element will be that numerical value. The second element is some logic we have taken and randomly running some numbers, so that we can get some uh, date, time, and seconds in 2017. These are all random. These are all random numbers. So we get some random numbers, but it is in the form of a tuple now. We take each element and transform it into a tuple. First element is 1, 2, 3, 4, 5 up to 54,000. The second element of the tuple is some random values, which will help us in creating the timestamp. So to those random values, we keep the first element as it is. To that random value, we are adding one more. These are all pre-computed. These are all pre-computed so that we get the timestamp as 2017. And since it is, if you see here, gen.ts generated timestamp. So if you hover on that generated timestamp, it is in the form of a collection of tuple. Range, when we say 1 to this, it is a range collection, we know that. A range collection belongs to indexed sequence. It belongs to indexed sequence. Hence you can see the data type of this is indexed sequence. Indexed sequence of a tuple where first element is a normal integer and the second element we have made it as a long. We just convert into again a data frame, that collection into a data frame with row number and generated timestamp. So we got our one data frame, which is this data frame. This is the data frame with ID row ID, and the generated timestamp. Now in our, we have to put this timestamp, newly created timestamp, to our sales data frame. How do we do that? We don't have a common column now. Now it is easy to generate again 1, 2, 3, 4, 5 up to 54,000. That's the reason we created this column. Just a numerical 1, 2, 3, 4 up to 54,000. The same thing we will create for our sales data frame also. So here what we are doing, we take our sales data. I will come to this Coalask here. We take the sales data, we are adding a new column called row num sales. With column will always add a new column. We'll add a new column. We are trying to add this column. So we take that sales data and we add new column, and the value for that new column, there is a built-in function called monotonically increasing ID here. So this is a built-in function. We should be able to use it. So there are multiple such built-in functions. All those built-in functions are available here. So if I comment this, you will get that error. So this function exists. So just import that. Use that function, it will monotonically generate a number, and we are adding 1 to that. So we will be getting just 1, 2, 3, 4, 5 up to 54,000. 5 lakh 54,000, 5 lakh 41,909. Now why we have done a Coalask? Now what is Coalask here? What is Coalask? Coalask is used to reduce number of partitions. That's the use case of QLASK. It will internally partition. Let's say your data was partitioned into 10 partitions and you wanted only 2 partitions. Your data was partitioned into 10 partitions. Your data frame was partitioned into 10 partitions, but you wanted only 2. You can use the QLASK. Whenever you want to reduce the number of partitions, use this. Now, why here we are using it? In our case, why we are doing a QLASK and reducing the number of partitions to 1. What is the reason behind that? The reason is this. So let's say we have our sales data frame. This is our sales data frame. Let's say it is in 3 partitions. This is partition 1. Similarly, we have partition 2, partition 2, and partition 3. So this is our data frame. Just like already exists, data frame is also, we know that it is a distributed collection. Only thing is we will have row 1, row 2, row 3, row 4, row 5, row 6, row 7, row 8, row 9, row 10, row 11. Let's say we have this data frame. Now when I use the monotonically increasing function, when we use this monotonically increasing function, so it will add a column with, we are using the with column. To this column, it will create those numbers starting from 1. So what it will do is, it will create a number 1, 2, 3, 4. For this also it will say 1, 2, 3, 4. Again for this also it will say 1, 2, 3, 4. For each partition it will start from 1. For each partition it will start from 1. But we don't want our data frame in that fashion. So how do we want our data frame? We want 1, 2, 3 up to 54,000, 5,49,000, something. We want from 1 to this. If we had some 5 partitions, you will not get the complete 1 to 5,49,000 if we had multiple partitions. With coalesce, what happens? Everything will move to one partition. So this partition may be, it will internally, the Spark will check which are the uh, lesser in size 2 partitions. Let's assume that P2 is smaller and P3 is smaller than P1. P1 is a larger partition. Let's say P2 and P3 are a bit of a smaller partition. Internally, when we say coalesce, one, it will move 2 partitions to one partition. So all these records will be moved here. So we'll be having only one partition. We'll be having one partitions. So the monotonically increasing will start from 1 and go on up till 5,49,000 and so on. So that's how the coalesce works. Coalesce is only used for reducing the partition, and it will move the other partitions to a single partition. If we had, let's say you had 4 partitions. Let's say you had four partition: partition 1, partition 2, partition 3, partition 4. Now after doing coalesce, you said two partitions. I want only two partitions. So it will move probably. I mean, one partition will be moved here, one partition will be moved. So this partition does not exist now. This partition does not exist. It will be this partition. So now you have only two partitions. So that's how the coalesce work. The use case we have seen here, because we want to have a number from 1 to the total number of records. Right. If the data is large, right, so it will be. I mean, you should not use coalesce and make it as a single partition. It's very rare that we will be doing a single partition. But if your data is too large, don't make it as a single partition. You have to use some other way of assigning a numerical values to our to your data. What could be any other way? Probably map partition will be helpful. You can use the map partition. For each partition, start the some logic we have to apply. I mean, it's not so easy. We have to think. Row number function can be used. A row number function exists. Yeah, I think there is a row number. Yes, I think we can use this. I had not seen this. We can check what is. Returns a sequential number starting with 1 within a window partition. No, I don't think so. This will also help. They say that within a window partition. Probably there might be some solution that could be used. A row number cannot be used. Again, it is with respect to some partition. It is with respect to some partition. But as of now, we'll move with this. I hope Saurabh, that is fine. As of now, we'll move with this the same. We'll continue with the same. But otherwise, there has to be some other solution. I mean, we can Stack Overflow it, so we may get some solution. So we have our new sales data frame with this row number, with this row number. So let's showcase this. Let's print these two things, and we'll also print these two. Rest will comment as of now. I'll comment this also because we only need this data frame and our new sales data frame. Later we'll be joining these two data frames. So finally, we have our sales data frame with this row number. Here we also have the user ID and our customer ID. So we have three data frames now. This is one data frame. This is also one data frame. This is also one data frame. So we'll join these two data frame using the row number column and we'll ingest the timestamp here. Similarly, these two data frame will be joined using the customer column, customer ID column, and then we'll ingest this column here. We'll put this column. So then we have modified our sales data frame. We have adjusted the timestamp in our sales data frame, and we also have the user ID in our sales data frame. So that was our final goal. While it is running, we will see the other logic. The next logic is simple. We take our sales data frame which also has the ID column, which is nothing but the numerical numbers that we join with our generated timestamp data frame using the row number 1, 2, 3, 4, those numerical numbers. So we are actually, once we join it, we don't need those columns. Hence we are dropping those columns. Those columns were generated just for the join purpose. After that we are dropping. And we are just giving a name, a generated invoice date now. We are converting into a Unix timestamp. After that again we drop this one. After we join that, join it with the customer ID and user ID data frame. Next, one more data frame where you join it using this column. Sales ID is equal to customer ID. and just rename the user ID to Omniture ID. With column rename, it will rename a existing column. With column will add a new column. With column renamed with rename a existing column. So this is the new column name. I think this is the existing column name, and this is the new column. So finally we and anyway these column IDs are also not required. We are dropping those things, and finally we are adding back our date TS. If you remember the reason why what I had said, we will drop the column. We had dropped the partition column. Again we'll add the partition column to the end. Partition column is again added to the end here. Because when we insert into Hive, Hive always wants the partition column to be the last column of the data frame. So that's the reason we are adding at the end here. And rest of the things are same. As I said, these things I should have put it inside a function and then call it. Rest of the things is same. So if you see here, row number and generated timestamp. Row number we have and generated timestamp. So our sales data frame will also have a row number now. From starting from 1 to 2, it will be having up to 5,49,000 rows. So once we join it, we will get a data frame, and that will be saved to a new table that will be created in the process to DB. Let's run this program once again with everything uncommented. So this time it will save the data to our processed DB, and sales table will be created. So if I connect to our Hive server, use processed DB, show tables. As of now, only Omniture table exists. Let's see how our sales table will now be creating our sales table. So if you go to the Hive warehouse, so there you will see processed DB. As of now, there exists only Omniture table. After running this program, it should create a sales table as well. I think the show is also there. Multiple actions will be called. Did I comment the show? The show is still there. I hope I have cached it so that it is being cached. So the multiple actions that we are running, it will not take too much time. So it is creating table if not exist, creating directory because table is nothing but internal to directory. So it has created the sales table, and it will be inserting the data into that. As of now, not much data will be there. It will be writing the data. So folder should also be, so sales directory got created, and our process is still going on. So once finishes, our data should be there. So it has exited with code 0 now. So our data should be there. Data in the sense a new folder will be created with the same date. So when you run it for 9 o'clock, 9 o'clock's raw data will be taken, raw sales data will be taken, and it will be created, a subdirectory will be created in the sales with 9 o'clock as the _9 as the folder name. So on for every partition and every new folder will be created. So we can check how it looks like. We can from our Spark Hive we can see that. Select star from sales, and just limit it to 10 records. So as you can see here, as you can see, a new generated timestamp is there, and the sales user ID is also there. So this was not part of the, this was there in the Omniture data, the same thing we have got it here. And this is our timestamp. So this was also not there. So actual sales was in 2010, as you can see. Now you can see that this is our, now we can say that these two data are related data. So just I was trying to showcase this ETL process. This is how you do. Even though the logics are are not, it will be as per your business logic, but the overall process will be the same. You will be ingesting the data to the raw database. You'll be doing some ETL and putting into the process database. After that, we'll be doing some more processing and putting into the warehouse database. Our second job is done. So this is done. Prepare sales data is done. We adjusted the timestamp and we changed the customer ID of the sales data. We, instead of change, included user ID from Omniture data. Finally created the processed sales Hive table and saved processed sales data to your processed.sales Hive table. To run this on the IntelliJ, from IntelliJ, you have to give the program arguments in this fashion and the folder name of the partition of raw.sales. What's the newly created? So for example, in this fashion, output will be, we already saw the output. Our next job is to sessionize. This also we'll see now, and we will end the ETL process here. So we have to read now both the processed data. So we have to read both this data. Now these two data are related. Now user has been doing the clicks in 2017, and the sales also happened in the 2017. It's like the same user has, while browsing, the user has purchased some data. That will map now. How many we will, which product was purchased in a particular session, that will be doing in our next job. Which product, because our browsing will have our start browsing time and the end browsing time. So the way we will map here is, so we have our Omniture data. So in the Omniture data, what we have is, we have certain fields. Along with that, we have session ID, and for this session ID, will compute start time and end time. Meaning a user started browsing at 7 o'clock and the session ended at 8 o'clock. There were continuous clicks here. These were not part of two different sessions. There were no clicks which were 30 minutes apart. There were no clicks. All the clicks were within uh, continuous clicks. Hence, let's say this is one session. Now we will take the sales data. We'll check anything is for this user ID. Here also we have, for this user ID, is there any sale between 7 to 8? Is there any sale happening? It means that user, while browsing the session, in this session, the user has purchased a product here. So that's what we are trying to do. So let's see how it looks like. So in that case, we have to read both our processed data. So read processed Omniture data from the processed Omniture table. Read processed sales data from the process sales table. Join both data so that sales are mapped to the corresponding sessions. Finally, create warehouse session mapped table. This table is also again partitioned on R the same way. Save the joined data to this warehouse map table. It is much more simpler than the other two jobs. So let's see how the code looks like. Actually, this project name should have been e-commerce sessionization. Marketing, there was small reason why the marketing came into picture. I will explain that. So if you see, last job is our map session sales. This is an optional. You can also find daily top spenders. These three jobs will be running on a hourly basis. This one job you can make it to run on a daily basis. You take all the partition of a one day and find out who is the top spender. Such things can also be done. So as you can see, as usual, we are reading our processed sales data with only that data which corresponds to the current timestamp. If it is running at 8 o'clock, it will only take the 8 o'clock's partition data. In a similar fashion, we are reading the Omniture data. Both the processed data we have, then we are calling our map sales to session. It is there in the session sales mapper class. You go to the sessions, there you will see session sales mapper class. In this class, that method has been written which will take care of the joining of your data. So how we are joining here? So we want to check for each user and for each session a particular users, and that user can have multiple sessions based on when he has logged in and logged out. So we are grouping by each session for each user and each session. Then find out the min start time and the start time of each session and the end time of each session. So we just use the aggregate function and call min of timestamp as a session start time, max of timestamp as a session end time. Session end time. So we get the start time of the session and the end time of the session. Then that data frame. Am I not audible? Hello. I think I am audible. Anand, just try to log out and log in once again. Yeah. As I was saying here, so we compute the start time and the end time per each session and for each user. Then that data frame we join it with our sales data frame based on the user ID, based on the user ID and the session, the sales generated invoice date should be within that time range, less than the end time, and it should be greater than the start time. Join those two data so we get the sales happening in a particular session, and that's how it looks like. Finally save that. Once we have that, again Again, as I said, all these things I should be putting into a one function, and I have to just say create data frame, create table from data frame, and insert data into the table. So let's run this program as well. Let's run this program as well, and let's check how it looks like. Again, before we run this, we have to specify the date. Date should be the same date. So what we did is this. We had our some let's say we have our server here which contains Omniture and sales. So this was ingested to HDFS. Let's say this is our HDFS. It was ingested to the raw DB. There we have Omniture and sales. Hourly basis. A new basis, hourly basis data is ingested. The very first job is Hive partition. Hive partition was done. This was our first job. Once the Hive partition is done, then we ran our Spark job 1, which is prepare Omniture data. We read this data, Omniture data, and save to processed DB. Our next job was job 2, which was prepare sales data, and saved it here. Our next job is a job Spark job 3. Spark job 3, which reads these two processed data. Does maps sales to session, and writes back the data to warehouse DB. Map sessions is the table name. So this is what the ETL process we achieved. So this is our data engineering team which is doing this ETL. This is our ETL. Once we have our ETL, once we have our ETL, once we have our ETL, so our data analyst team will come and they will be giving the query on these things. So the queries are queries you will be using our Spark shell. As I said, Spark shell usually is kind of your console based BI tool, or you can use Hive Hive beeline client, or usually, or you can use some BI tool, ClickView or Tableau or Zeppelin. All those BI tools could be used. If you are using Beeline, so you will have our Hive server here. Give the queries will be run on this. If you are using Spark Shell, so our Spark will come underneath. So the queries will go there and it will give the results. So your Spark Shell usually comes at this end. So let's once this is done, let's give that query. So this has exited with code 0, meaning our map sessions should also be created. So if I go to warehouse DB, if you go to warehouse DB, you can see that session underscore map is created and a particular directory exists. So that ends here ends our ETL process. I will just complete because this will again take 5-10 minutes. I will just finish it because I don't want this whole thing, just this part, to be in a separate video. If it comes in a one video, so it will be easy to follow. So next step is to give queries on our session underscore mapped table. Querying the processed DB. This querying is our data analyst team will be doing. So we can start our Spark shell in this fashion. Here MySQL connector jar is used so that Spark shell can connect to the Hive metastore. That's the reason. We'll just start the Spark shell. So you have to write this piece of code. So these are the queries. Sessions which resulted in a sale. Sessions which did not result in a sale. Total invoices per session. Distinct products sold in a session. So these kinds of queries or some other queries can also be given. Yeah, my ETL process is running, right? So it is using this 4040 port. So that port is not being used. It will take some other port now. So if I go there, just copy this command and type it there. Import Hive context. Create your Hive context and read warehouse. Just remove this show part. Read your warehouse session mapped. So I should also include filter it by, but let's, because that's the only folder we have, we need not to filter. So session underscore mapped. So it will just show the first 20 rows. Just to showcase that we are able to read this data from our Hive table. So Spark Shell is able to read the data from our Hive table. So it is able to read it because we have copied the Hive site.xml conf file to the Spark conf directory. I had shown that earlier. So we are having our user ID, session, session start, and session end time. So these three things we created. We have also have invoice number, stock, description. The session, the clicks data or the Omniture data, and we have the sales data joined together. Now we can give certain queries here. So these are the sessions which resulted in a sales, not none. Filter all the records which is invoice number is not there. So all the sessions which resulted in a sale. I mean different queries can be given. I have just have these queries. All the sessions which resulted in there where there was no sales at all. These are the sessions where no nothing was there. So probably what next stage could be, you can feed it these things you can feed it to some machine learning algorithm. I mean this data can be given to the machine learning algorithm team, so they can put some algorithms and find out when and where a user will usually purchase a product. They can predict the customer behavior, whether the customer is going to purchase this product or not, whether in a particular in this session the whether the customer is going to purchase any product or not. So based on that, later we can some marketing notifications you can send for a particular product. So that's where that marketing came into picture. So this data you can feed it to any machine learning team can take this data and do some analytics. So I hope this end-to-end pipeline was clear. So what the final thing I said, that this data can be given to uh, ML team, machine learning team, data scientist. Data science team it could be given, and from there they can come up with the model and do prediction. So I hope these things were clear. I I hope the end-to-end pipeline how works it is clear. The only thing is we ran it in the development mode. So I will showcase it on the multi-node cluster. I will showcase it how it runs with the help of Oozie automation framework. So that probably I may not be able to show tomorrow because I have to set up the AWS cluster. I will set up that AWS cluster once that is up and running. It then I will showcase. So thanks everybody. Thanks everybody. Uh, have a nice day, and others good night.